now that we have a kind of baseline understanding of a lot of the the underlying technology and the capabilities, um, there's still situations we talked about where it makes sense to use optical encoders. You want to just quick cover when when it would make sense to use an
Yeah,
optical encoder.
I think there's two or maybe three places where I would, if the resolution requirement is extremely high, um, again, well, today our max is about 14 and a half bits. I think we'll get to 18. Beyond that, optical encoders will get to live until we come up with some technology that we haven't thought of yet. The other place is, there are certain, if you're looking for a module, cost is no object, and you're looking for a module, especially some of these encoders are ingress protection rated, IP rated. They're, I used to sell optical encoders in my previous life, and some of these things are $300-400 because they've got ingress protection rating. No water, no dirt, no dust gets in there, and it's just a module that you put it. Literally, you just bolt it onto the end and tighten a screw, set screw into the shaft of the motor. So those are the places where I think we'll continue to see optical for a while. The places where you see or used to see them in consumer and to a certain extent industrial. I think those are going to go away eventually because there's just the hill that you have to get over is this kind of like, well, we got to put in the upfront work, right? It takes, when you have an optical encoder and you just plug it on there, set screw, we know it's easy, we got it. And I go in and I say, hey, you should take a look at a magnetic sensor here. And customers say, yeah, magnetics. So I got to deal with the new magnetic material, and it's a new magnet supplier. I got to do some mechanical work. Obviously the output might be different, especially if you're using one of the one thing I'll say for the optical guys is they did a good job of having proprietary communication protocols. So you'll see like INDAT, I forget, all of them have their own flavor, and they do it on purpose, so it makes it difficult to so that's potentially a control change. But eventually the benefits are there, and the benefits are high enough that eventually customers are gonna have no choice but to say, okay, you know what, this year we're going to tackle this upfront work and save all the money on the back end. And a pitch for myself, that's the fun part of my job. That's what I'm here for, is to walk customers through that. And there's nothing I love more than getting a step file from somebody and that says, hey, here's some mechanical constraints, here's what we can do, here's what we can't do. I run some simulations, send it back to them with some, and we iterate back and forth. That is literally the most fun part of my job, and it's really satisfying because at the end we have something that saves the customer generally significant amounts of money, and now we have business. So it's classic win-win. It's what I like.
With it sounds like with optical encoders, if it's a, let's say, a plug and play smaller volume application, that's a reason, and there's not space constraints, cost constraints. If that's a small part of your bill of materials of your project, if you're doing a custom robotic arm, you're doing some custom machinery, an optical encoder is a reasonable solution in those situations because
I mean it's ease. If you don't have those constraints, if you don't have cost and you don't have size and you don't have then why put the work in to make the change if it's not right. But those are, we're relegating the optical encoders. I think now we're getting relegated to more and more niche space, because what applications out there don't care about size and cost? It's not so many anymore. It's very specialized stuff.